Ta-da-da-da. Welcome to our group assignment. This group assignment is proudly presented by S. Rupa, Aina, Ragu and Fahiem. Today we would like to present about active and passive elements. Passive element is an element which influence the flow of electricity running through an element. So passive normally resists the flow of energy. It usually it usually cannot control and amplify electricity by itself. For example, passive element consists of resistor, capacitor and inductor. The opposite of passive element is an active element. Active element is an element which requires source of energy in order to perform its function. So this active element can manipulate the flow of electricity. Meanwhile, passive element could not manipulate the flow of electricity. So examples of active element is transistor, diode and diode. So we will move to the next page. Okay. So in a circuit is divided into two, which is parallel and series circuit. I guess everyone knows about series and parallel circuit, so we will go through quickly. So series circuit is a circuit where the current flowing through the circuit is in same amount in any area of the circuit. So if you use a ammeter to record the current in any part of the circuit, we will get the same reading. So in this circuit, the components are arranged in a straight line, not really straight line, in a line. So this is what makes it a series circuit. It doesn't have any cabang-cabang. The resistor in this circuit is different even though the current flow is the same. So if one of the components in the circuit breaks down, the whole circuit will burn out because the current could not be transmitted from one point to another point. So the equation for this voltage is V1 plus V2 equals to V3. This shows that the voltage at any point of the circuit is equal to the total voltage. The next is parallel circuit. Parallel circuit is the circuit where the current flowing through the circuit is combined to form the current flow through. For example, if we have three components, the current flowing through the circuit is equals to I1 plus I2 and plus I3. And in parallel circuit, the components are arranged parallelly to each other. An advantage of parallel circuit is other components still function even one of the component breaks down. So it's better to have a parallel circuit compared to a series circuit. And the total voltage of parallel circuit is equal in every point. For example, V1 equals to V2 equals to V3. So it's in parallel circuit, the amount of total voltage is not sum of every voltage. It's equal to a voltage. Next is independent and dependent sources. So these two principal type of source, which is voltage source and current source. So these sources can be divided either dependent or independent source. Independent voltage source maintains a voltage which is not affected by other quantity. So this proves that when there is other outer quantity or outer current sources, it will not affect the independent voltage source because this voltage source doesn't depend on them. It works by its own. Meanwhile, dependent voltage source is affected by them. Is or control voltage source. It is controlled by other voltage source. So this independent voltage source to take a voltage which is different from its defined one. It is not possible for it to take a different defined voltage. So Two particular examples are short-circuiting an independent voltage source and open-circuiting an independent current source. The examples are below. So both are not permitted. The next slide is Ohm's law and current divider law. As we all know, Ohm's law is V equals to IR. Ohm's law states that voltage across a resistor is directly proportional to the current flow through the resistor. Meanwhile, current divider rule states that how much of current flow through each branch is in a current divider. The next, okay, we will discuss about inductor. So the question is, what is inductor? Inductor is a passive component which stores the electric energy in a magnetic field when the electric current passes through it. We all know that when electric current passes through a metal or a steel, it will produce magnetic field. So we can call this electric device which possesses the inductance, which provides the magnetic field. So there are few methods to increase the inductance value. To increase the inductance value, we have to use magnetic core material with high relative permeability. This will increase the lines of magnetic wave that is produced, and this will surely increase the inductance. Next is we must increase the cross-sectional area of a magnetic core material through adding magnetic core thickness. So more the thickness, the more the current could pass through and more the inductance will be provided. And increasing coil length, which means we have to decrease the coil width and pitch between the adjacent coil for a certain value of surface area. By increasing the coil length, also increasing the we are also increasing the number of magnetic wave produced. So the inductance of a coil can be increased by placing a magnetic core of ferromagnetic material in the hole in the center. The magnetic field of the coil magnetizes the material of the core, allying its magnetic domain, and the magnetic field of the core adds to that of the coil, increasing the flux through the coil. So the more the flux, the more the inductance and electricity is produced. So last slide is that application of inductors. So these are the few application of inductor in our daily life. The first is filter. So inductors are used extensively with capacitor and resistor to create filter for analog circuit and in signaling process. Alone, an inductor functions as a low-pass filter since the impedance of an inductor increases as the frequency of a signal increases. So when the frequency increases, it is more useful for the inductor to be used in filters. So the next example is sensor. Sensor is a contact lens sensor are prized for their reliability and ease of operation. Inductor sense magnetic field or the presence of magnetically permeable material from a distance. Inductive sensors are central to nearly every intersection with a traffic light that detects the amount of traffic and adjusts the signal accordingly. So this proves to us that inductor plays a really big role in sensors. So
Okay, for question number 3, capacitor. The definition of capacitor is a passive element that is used to store energy in its electric field. Okay, itu the definition. The method to increase its capacitance value is the first one, increase the plate area. Capacitance value will increase with increase in plate area. And number 2, decrease the spacing between the plates. Capacitance value increases as the spacing between plate decreases. And the last one is applications of capacitor. The first one is storing energy in a camera flash circuit, and the second one is smoothing the power in a power. This is question number 4. This is the original one. This is the circuit after it is under DC conditions. So as we know that for for capacitor, it will become the open circuit here. This one is inductor, will become short circuit. Okay, so there will be no current flowing through this this circuit, because it is open circuit, so there will be no current flows. So for the first question is we need to find current. So as we know that this is a parallel circuit, so we use current divider rule. So R1 over R1 plus R2 times voltage, so 1 over 6 times 12, we got 2 ampere. So the second one is to find voltage in this circuit. So again, it is parallel circuit, so voltage will be same across any resistor. So we use voltage V equal to IR, so 2 ampere we got from here, times with 5 ohm here, this part, so we got 10 volt. Okay, so question B, in question 4, energy stored in capacitor and inductor. So just now we got capacitor is 1 farad, inductor is 2 henry, voltage 10 volt, current is 2 ampere. So energy in capacitor, we use this formula, energy half capacitor voltage square. So okay, we just use okay, so we got 50 joule here. Energy inductor 1 over 2 inductor times current square, so 1 over 2 times 2 henry times 2 ampere to the power of 2, we got 4 joules. So that's all. Thank you.
Okay, well, let's do number 5. Okay, here there's a 2 diagram here, diagram A and diagram B. What is the difference in this diagram? This diagram is we redraw after we using DC condition. What is the DC condition actually? DC condition is capacitor acts as an open circuit and inductor act as a short circuit. Now both sides are the capacitors, so our DC diagram, after we using under DC condition, our diagram will be like this. There's a 2 open circuit which replace the both capacitors here. Okay, now we should find the current flow using CDR. Okay, now we just use that 3 main resistor which only current flow over here, because there is no current flow over this 5 kilo ohm resistor. So well, we are now using CDR should find the I value. So 3 over 3 plus 2 plus 4 times 6 milliampere, so it's equal to 2 milliampere. Now we can find the voltage across here. So V equal to IR, 2000 times 2 milliampere equal to 4 volt, and V2 is I. It's the same formula, it's 4000 times 2, we get the 8 volt. Okay, now we should find the energy stored in capacitor 1, which is in across V1. If the energy stored in inductance, it will be 1 over 2 I and V square. It's now is we using capacitor, we must use the C value here. So 1 over 2 times capacitor value and times 4 square is equal to 6 millijoule. And energy stored in capacitor 2 across V2, it's 1 over 2 C2 V2 square, and 1 over 2 4 times 10 power of negative 3, it's over here, so it's time 8 square, which is V2 we got find before, and it's equal to 128 millijoule. That's it. Thank you very much.